Hey class, we're here again today for talking about combinations of functions today. So we already know that you're able to, with a function, you put an input, you put something here and you plug it in the function and you're able to get something out of the value for your input. You get an output for it. Now, there are many things you can do. With functions. That's why it's called the combinations of functions, because you're able to take two functions, right? Let's call them f and g. They can be combined to form new functions, f plus g, f minus g, f times g, or you put a little dot here, you fill in that dot, and f over g. So what this is saying that you're able to add, subtract, multiply, and divide these functions. Now, for the definition for that, so here's the thing. You're able, not only are you able to do these four things, but only with functions, you're able to do something completely different. And we should call this the inception, or if not, the composition, if anything. That's what we call this, composition, because you're able to take a function and put it within another function and you'll get something brand new. And vice versa. You can take, well, I'll explain more when you actually see it, what I'm talking about, but we call this new operation composition, where you keep the circle open. You don't fill it in like multiplication. So this would be called a composition of another function. So let me write what that means. Given two functions f and g, the composite function f composition g is defined by f composition g of x times like this, and then you get f g of x. So it looks something like this, where you see that this g of x is a function, but it's being put inside another function. So visually, what would that look like? So visually, you want to think of it this way. You first start off with your input x, whatever that value is, it could be whatever. And you're putting this into this giant machine. It's sucking it in, and this is your usual function g, and it spat out g of x. Now, what I'm telling you to do now is that we have another machine here that's going to suck in this function here, and now it spits out the new function f of g of x. You see how you're able to, well, if you can't see it from there, you just put over here, f composition g of x. So it spat out that function and you get this thing left over. So like I said, it's inception in the sense of you have a dream within another dream. You're able to take a function and put it within another function, getting something completely new. So visually, it will look something like that. And let's try a physical example. So let's say I gave you this function here. So if I gave you this example that says f of x is equal to x squared and g of x is equal to x minus 3 now. So, and I'm asking you to find, and I tell you to find f composition g and g composition f. Now I'll explain those two in a second. This is the part that I was telling you about, where you take this function g and you put it inside this function f. Now what I'm telling you is with this one, you can take this function f and put it inside of g. Does that make sense? So it'll make sense with this example. So let's do f composition g, which just means is whatever my g of x is, I'm putting it within this function. So it'll look something like this. You plug in what g of x is, so you have f of x minus 3. So now you take this and you put it inside here, you get parentheses x minus 3 getting squared, and if you expand this, you should get this is your answer, x squared x squared minus 6x plus 9. Now if I were to take the opposite, g of decomposition f is just g f of x, which is g of x squared. So that just means I have to just put this x squared into here, which just means parentheses x squared minus 3, which is just still x squared minus 3. So ideally, composition of functions, you want to be very careful of how you plug it in and how you word it. And it's good to go slow to see where am I plugging in g of x. I plug in the g of x into this, and it says, okay, f is x minus 3. This is my input, so I put this in here, and that's my output. So compositions of functions aren't too bad. I actually enjoy them. They're not too difficult in my opinion, but there can be some crazy ones. Don't get me wrong, there's some crazy ones that I don't like. But that's the idea. You want to get used to understanding that you're able to combine these functions with the traditional operations of addition, subtraction, multiplication, and division, but you added this extra element of compositions of functions, which gives you something new. So that's the lesson for you guys. This has been Absolute 5. I'm Roger Palomino, and math is infinite.